Well, hello everyone, and thanks for tuning in today. My name is Kate Tarrant, and I work for the Lower Blackwood Landcare Group based in the southwest of Western Australia. For those of you that don't know us, we're a not-for-profit independent land care organisation with an interest in sustainable agriculture and the broader environment and river health in the Lower Blackwood catchment. You can find out more about us and the work we do on our website at lowerblackwood.com.au. Today's webinar forms part of a collaborative project with RegenWA called Make Your Hectare Count. The project is supported by funding from the West Australian Government's state NRM program. And also, before we kick off, I would like to acknowledge that our Lower Blackwood catchment and the work we do falls within the Wadandi and Pilbara Budger, within which our streams and tributaries flow to join the Gorbulup or Blackwood River. We recognise and respect that Wadandi and Pilbara ancestors and their descendants are the traditional custodians of this country, and that they have a long and continuing connection to this land. Just a few words about how the webinar will run today. You may have noticed by now that you can hear us and not speak yourselves. That is deliberate, so we can keep things moving along at a good pace. You can definitely still ask questions though, so please don't be shy. Just type your question anytime into the chat box and I'll make sure it gets asked at the end of the presentation. Also, if you do run into any technical difficulties, please let me know via the chat box and I'll see if I can fix it from our end. Don't worry though, if you do have to leave early or drop out, as we are recording this session, which I will email out to you all next week. All right, so now to the reason you've all tuned in. I am delighted to have presenting to us today entomologist Dr. Anthony Rice. Ant, as he likes to be known, holds a PhD in insect ecology from the School of Agricultural Science at the University of Tasmania and has worked in plant health for the past 25 years. 10 years ago, he started his own integrated pest management consultancy, Granite IPM, and has subsequently delivered countless training workshops and presentations throughout Queensland and the Torres Strait, as well as in Pacific Island countries and Southeast Asia. And is passionate about getting information out there on a different, more ecologically friendly and ultimately more sustainable way of managing pests on the farm, horticultural enterprises, or the home garden even. So today's webinar is going to dive into the world of IPM and how we can reduce our use of pesticides by using bugs to manage other not so welcome bugs. So without further ado, I'd like to welcome you, Ant, and I will hand over to you.
Great for that wonderful introduction and welcome everyone. Today we're going to be talking about harnessing the good guys. How can Australian agriculture help us avoid our own insect apocalypse? The underlying theme with this talk today is going to be about the army of beneficial insects that deliver an enormous amount of background control that you may not be aware of, and how we can end up improving their efficacy in the field. So what are the natural enemies that I'm talking about? They call them good guys, good bugs, beneficial insects, natural enemies. I'll use those terms sort of interchangeably today. And many of them are actually available for purchase commercially. They are an army of insects that just want to eat our pests. They've been doing it for millions of years, and they would happily go on doing it for probably millions more years after we've long gone. And all we have to do in agriculture is to stop killing them. So more specifically, I'm going to be talking about why we need to change, and that actually forms a large part of this talk today. Why do we need to change what we're doing in agriculture now? I'm going to talk about what is IPM and how can we apply it at your patch using beneficials, again, that you already have. The large focus of it will be in commercial horticulture because that's where most of my experience is. And then at the very end, we'll talk about a case study at your request, Kate, of IPM in red-legged earth mite. So how did we get to where we are now? Prior to World War II, sulfur, neem, some heavy metals and a few botanicals, things like pyrethroids, or actually it was pyrethrum in those days, formed the mainstay of pest management systems, especially on a commercial scale. But during the Second World War, there was a lot of research went into chemicals that will kill us. They found that not only were they very good at killing people, but they're also very good at killing insects. And that's when we realized that the insecticidal properties of organophosphates, carbamates, organochlorines, etc., including DDT, was realized. They were very, very effective at killing pests, but this led then to an increased reliance on them. I guess because they worked so well, we just kept using them. But in turn, this has led to what they called at the time a chemical crisis, whereby more and more chemical was required to do the same job. This was largely due to resistance. In 1962, Rachel Carson published her groundbreaking book, The Silent Spring, and it documented the environmental harm caused by indiscriminate use of pesticides, especially insecticides. It sort of heralded the beginning of mainstream environmental awareness, and at the same time, the American chemical giant Monsanto published what was essentially a rebuttal of Silent Spring. It was called The Desolate Year, and it came out in the same year, 1962. And it essentially told the story of a town that didn't have pesticides and how they lost all of their crops and ended up dying of starvation. It was a little bit clumsy, I suppose, but it was actually made a really good point. So while we have the beginning of mainstream environmental awareness, what I call the environmental camp, we also then had the chemical camp. And we've still got that dichotomy today where the situation is still very confrontational. There's not a lot of give and take, but there's an enormous amount of middle ground, and IPM sits in that middle ground. And if we can get it working, we should be able to significantly reduce the impacts that agriculture is having on the environment. So the term integrated pest management was popularized in the early 70s, and there was a concerted effort to bring it into mainstream production systems. It endeavored to make agroecosystems more sustainable and reduce synthetic pesticide use. But 60 years later, about 90% of plant health programs still rely on chemical intervention. We jump forward to 1992, and a couple of important things in this story happened then. So the world scientists released a manifesto called World Scientist Warning to Humanity, and this document highlighted things like climate change as a dangerous process, overpopulation, resource depletion, that sort of thing became pretty controversial in those times. And this was a warning to humanity to start looking ahead and dealing with some of these issues. At the same time, same year, a brand new product came out on the market called imidacloprid. Now, imidacloprid is the active ingredient in a product called Confidor. And it was the first of the neonicotines that hit the market. It's highly persistent, water soluble, and systemic. But the really important part of its characteristics, as with the other neonicotines, is they are effective insecticides at extremely low levels, and this makes them environmentally very dangerous. So moving on to 2020, scientists released a scientist warning to humanity on insect extinctions, and it highlighted this general decline, dramatic decline in insect numbers all over the world, and how it was likely to impact us. At the same time, the neonicotine imidacloprid becomes the world's most commonly used insecticide, and it still is the world's most commonly used insecticide by a very, very great margin. So what is the insect apocalypse? Now, the estimates vary, and the decline is not evenly spread, but it generally is describing a global decline in insect abundance and diversity. So long-term data, the bit of data that we do have, indicates between 40 to 75%, and even some cases as high as 90% reduction in insect abundance. And you can look online and there's numerous examples, there's numerous reports of scientific studies finding this. For example, it was published in Science, the global monitoring data for 452 species, there was a 45% decline in invertebrate populations over the last 40 years. One of the things that's really disturbing is that not much of this data has come out of the tropics, and over 80% of insect species occur in the tropics, though most of them are undescribed. We don't actually know what they are. But we have almost no data from these regions. Flying in the face of that, a fellow called Krosky published a very comprehensive study that found no net insect abundance or diversity declines across the US. So this flies in the face of all those other studies. So it shows that really the picture isn't as clear yet as we hope it is. So where have those studies mostly been carried out? In a review of the drivers of insect decline, these authors gathered as much information as they could and investigated what was causing the decline. And the number one driver they found was habitat loss. But if you look at where these particular studies were carried out, most of them are in Europe. And Europe has a highly disturbed landscape. It's one of the most densely populated regions of the world. It is mostly disturbed, the countryside is mostly disturbed by urbanization and agriculture. So it's not surprising that the majority of studies has found that. You can see from this map that there is an absolute dearth of data coming out of the tropical regions of the world. And where most of our insect diversity is concentrated, and other invertebrates as well, it's really concerning that we don't have this data. I'll tell you another reason why it's concerning later on in this presentation. So if we've moved from a reliance on organochlorines, products like chlordane, aldrin, heptachlor, those old nasty things that were very persistent in the soil. Most of those now have been taken out of registration. You can't use them in agriculture anymore, which is probably a good thing. We've moved on to organophosphates, which tend to be less persistent in the soil, but they're still very toxic. They're useful products in their place. And then we went from organophosphates into neonicotine. So we've sort of gone, every time we make this big change, we jump out of the frying pan and back into the fire. So in the US, community-wide declines in butterflies are strongly associated with the use of neonicotine seed treatments. I'm calling them now, from now on, I'll call them NSTs, save a bit of space. So in the UK, agriculture applications of NSTs are associated with decreases in abundance of bees and butterflies, while bee declines have also been associated with the applications of neonicotines. And again, there's countless studies. I could have used dozens of them as examples here. So if you just want to look online, you'll find a lot more examples of this sort of work. National Geographic Online claimed that America's agriculture landscape is now 48 times more toxic to honeybees and likely to other insects than it was 25 years ago. And they ascribe all that to the use of neonicotines as well. One of the things about neonicotines, which is, I guess, a little bit disheartening, is while they've been described as a worldwide threat to biodiversity, they've been banned for outside use in Europe, but they're still allowed to manufacture them. And they manufacture them in huge quantities and export them to countries that don't have the same kind of legislative restrictions around how they're used. So if we jump forward to 2025, what's happening now? In Europe, 3 have been banned for field use since 2018, but they're still manufactured and exported. They're a very profitable business. One independent financial prediction from a company who does this sort of thing put it at about 8.2 billion, worth about 2 billion by 2035, I think it was. So it's huge amounts of money, a very, very profitable business. So they're still manufactured and exported from Europe. Greenpeace claims that 13,000 tonnes was exported in 2021. And I'll tell you why that's a significant amount. That doesn't seem that much when you compare it to some of the other pesticides that we put out, but I'll explain why it is. So in the US, it's been implicated, neonicotinoids have been implicated in colony collapse disorder of bees. 86% of honey is contaminated with at least one, 75% have got two, and about 10% have been contaminated with 4 or 5 neonicotinoids. So Australia has 6 neonicotinoids now registered for use. The APV is reviewing its regulatory decisions on neonicotinoids. One of the things that's always sort of puzzled me is why the names of these neonicotinoids are so hard to pronounce and so hard to remember. Even spelling them, I still trip over them when I spell them, and I've been doing it a lot lately. So I've always wondered, and I know it's a little bit of a strange thing to wonder, but I've always wondered if they're so difficult to pronounce and remember, and that it would make it harder for people to discuss them. So here I am, I'm going to say them out loud. There's many of these I've never heard spoken, but I'm relying now on the rules we use to name insect species. We often rely on the Latin names, and in Latin you put the emphasis on the suprapenultimate vowel, which is the third one from the end. So we have acetamiprid, clothianidin, dinotefuran, imidacloprid, thiacloprid, and thiamethoxam. And now we've got something you can talk about over dinner tonight. So the Chief Scientific Advisor for the Department of Environment in the UK has said that the current assumption of underlying pesticide regulation, that chemicals pass a battery of tests in the laboratory or in field trials, are environmentally benign when they're used at an industrial scale, is false. And it highlights the fact that our testing of these products is not up to dealing with things like these neonicotinoids, and I'll talk a little bit about that in a moment. So why should we care? Well, when you can compare vertebrates to invertebrates, there are roughly 60,000 species of vertebrates in the world. Those are animals with backbones. Invertebrates, there's about 30 million species. That's a ratio of about 500 to 1. They, class Insecta, outnumber all other animals on Earth, 1 to 5 million species. They are involved in almost every aspect of our food web and our natural ecosystems. They're involved in specifically things like nutrient cycling, pest control, pollination, decomposition, and they are the main diet for numerous birds, bats, and fish. So irrespective of the fact that they're absolutely awesome, we should be looking after them. Just a little bit more on the ecosystem services that they provide. I've grouped the vertebrate species that most people are familiar with, and in this table we've got the estimated number of species that there are globally and the estimated number of species that rely on insects. So birds is a really firm figure. It's about 97% of bird species rely on invertebrates and insects in particular. Reptiles, it's over 90%. Mammals, it's about 100%, either directly or indirectly. And fish and amphibians are again around 90%. So without insects, the world's ecosystems will collapse and our food web will no longer support us. So neonicotinoids have been described as maybe the single greatest threat to our landscape functionality we have ever faced. Now, why would somebody say that? Probably the main reason that's driving this spotlight that we're seeing on neonicotinoids at the moment is how toxic they are, how toxic they are at such low levels. So the LD50, an LD50 is the lethal dose to kill 50% of a population of your test animals, whatever it is you're testing the toxicity on. The LD50 for bees is 5 nanograms. Now this is 1,000th the LD50 for bees for DDT. It goes to show just how toxic they are, but if you wait longer than that, it can be as low as 4/1000ths of a nanogram, which is called a picogram, 4 picograms, which is 1/1,000,000th of the LD50 for DDT in bees. It shows just how toxic they are. So at these rates, OECD protocols, and I don't know why they're the holder of these protocols, but they are, and these protocols dictate, and they're a resource for governments, they're a resource for universities and students and chemical companies as a way. It's a common protocol used to test lethality and toxicity of insecticides. So at the moment, the protocols don't expand over the number of days it takes for neonicotines to kill bees. So our testing is not up to speed anymore. In sunlight, imidacloprid and clothianidin, they are the main ingredients in commercially available seed treatments. The lifespan can be days or weeks. But if used in seed treatments, they're burrowed away down into the soil where the sunlight can't get to them, and they just don't break down at the same rate. So the half-life can be years, and up to 19 years for clothianidin, as reported by the EPA in the US. Most measures are substantially shorter than that, but they did have one study where they gave up because it just wasn't breaking down in the soil. So according to the APVMA in 2023-2024, Australia purchased and used 67,104 kilos of imidacloprid. It was again in Australia our #1 insecticide that we bought and used. That is, if you divide that by the lethal dose for bees, it's 1.3 times 10 to the 16th lethal doses for bees. Now, a bee weighs about 30 milligrams. That's average. You get heavier and lighter ones. And I'm calling that my honeybee equivalents. So the global dry mass of terrestrial arthropods, an arthropod is an organism that has an exoskeleton with jointed legs. So it includes things like centipedes, scorpions, insects, those sorts of things. The global dry mass for terrestrial arthropods is about 300 million tonnes. Therefore, in Australia in 23-24, we used enough imidacloprid to kill every terrestrial arthropod on the planet. So there's some reasons why impacts are likely to be underestimated here in Australia, probably elsewhere in the world as well. There's with the lack of data that we have here in Australia, there's a lot of work going into almost a scrambling to find out what's happening to our insect populations here in Australia. There's a widespread recognition that remnant vegetation and agroecosystems represents a very valuable resource to stabilise our insect populations. Now, this photo here I took a couple of months ago in the Darling Downs region in southeast Queensland. And the paddock on the left here, they grow a lot of things like sorghum. I might just click on this pointer, make sure it comes up. Yep, that paddock there. They grow a lot of things like sorghum, sunflowers, maize, that sort of thing here, and they generally use a lot of neonicotine treated seed. If that was planted as per label rate, or they bought the seed already treated, per hectare, about 51 grams of neonicotines seed treatment goes in per hectare. Now, the uptake of neonicotines in maize is less than 2%, which is appallingly low considering the environmental harm that these things could be causing. So you end up with 50 grams per hectare left over in a paddock. Where does it go? Well, if you assume that it doesn't rain, then most of it will stay in the soil. If you apply amount X in year 0, that's when you go out and put your first neonicotine seed treatment in, and you apply it every year, which is common practice, the neonicotine level in your soil won't plateau for nearly 15 years. And you end up with nearly 8 times the original amount that you've been putting in. Unfortunately, it does rain. It rains heavily in Queensland when these big storms come through. And it gets washed out. It gets washed out from your paddock in the groundwater, to the groundwater, in runoff, and it ends up in the creeks. We know that waterside vegetation, riparian vegetation, will take up neonicotines via their root system, and it will end up in pollen, it'll end up in nectar, and it has the potential to toxify the very remnant vegetation patches that we're seeking to use to stabilize our insect populations. So you might say, well, that's just a cost of doing business. We need them, and we just got to suck it up. And in many cases, they might be right. But the fact of the matter is that we just don't need them. In France, there are 3 published cases where governments have had a genuinely in-depth look at whether we need to use neonicotines. One was in Europe, and it was shortly after they were banned. There was a moratorium on them, and this study was used to eventually place a ban on them. And they found that in 97% of cases, neonicotine seed treatments were not useful, or there was a viable alternative to them. In Canada, a similar long-term study found in 95% of cases they weren't useful. In the US, they did a study on soybeans, and this was a long-term, went over several years, many tens of trial plots over a long period of time, and they found negligible benefits. So we don't need them, and this one's a real eye-opener. In the 1990s, about 50% of corn in the US was treated with an insecticide. By 2011, it's gone up to 100% are treated with neonicotine seed treatments, with no appreciable increase in pest pressure. And that's the key to this. We're using them more, seemingly without any reason. We just seem to be addicted. I cannot fathom how we've got to this stage. So an addiction is an inability to stop doing or using something harmful. And that's the last of the doom and gloom. Now I'm going to talk about something a lot more interesting. What is IPM and how can it help? So IPM, it can be defined in many ways, I suppose. But the most useful one is a series of management practices that uses a range of techniques to suppress pest populations below economic thresholds. Excuse me. But fundamentally, they should be based on comprehensive population data from your crop on both pests and beneficials, and they should also allow for, in principle and practice, sub-economic pest levels. I'll talk a little bit more about thresholds and sub-economic pest levels in another slide. So the blue box here is the common IPM paradigm. It's the way that I was taught it. It's the way that they unfold. It's a hierarchical process that goes over time and also over the lifespan of your crop. So we start off with what we call cultural techniques. It might be, I don't know, rotary hoeing past crops to make sure there's no pupae overwintering for the moths to come out and attack your crop. It might be using varieties of your crop that are resistant to insect vector disease. There's all sorts of things that go into the planning, and we call them cultural techniques. So imagine you set up your farm, you've done as much as you can, and then the pests come in. You might be a fly in, they might have erupted from the soil. However they've got there, you might need to now up the pressure a bit on your side. So you might look at biological control. You might go to some of the big companies that sell biocontrol agents and buy predators or parasitoids from them, and that's what we call biological control. And a few weeks later, you might find, no, the pests are building up again. I've got to do something else. And then you might look at a biorational pesticide. Now, biorational pesticide is one that has some natural element to it. So it might be botanicals. It might be something that's really not harmful to your natural enemies. And that's what we call a biorational pesticide. So you put that on, and eventually you get to the stage where you've got a good crop, you need to protect it, pests have come in, and you've got no choice now but to resort to chemical control. So you first pick something that's narrow spectrum, and then right at the very end, when things look like they're going pear-shaped and you need to protect your crop, you might go something more broad spectrum. If you go through this decision-making hierarchical process, you will spray less, and that's the very heart of IPM. It's a big ask, though, for people to take on. It's a lot to get your head around. And what I found in my experience is that there are 8 first steps that you can take before you even go down this IPM pathway that will help set up your crop and your farm and your machinery and yourselves and the way you think about pests. It'll help you set up to spray less, to start using that army of natural enemies I talked about at the very beginning that you already have in your crop. All you've got to do is stop killing them. And I've demonstrated this to myself several times, and I know it works. So what's the first one? First one is, here we go again. Stop using neonicotine seed treatments. I've talked about the possible environmental impacts that they might have, and now I'm going to talk about why they're not IPM compatible. The first reason is that seed treatments are universally used against a pest used for a pest problem that doesn't exist. It's like an insurance policy. We've become so risk averse that we're not prepared to take the risk that something might come up. And instead of dealing with it when it does come up, we try to deal with it just in case it does. Science tells us that we don't need them, and I've already been into that, so I won't bang on about that anymore. Another thing that's a bit worrying is there's no data to say what happens to natural enemies when they feed on treated pests. So things like aphids have already become resistant to some neonicotines that are used in seed treatments. So if, for example, a parasitoid or a predator fly in and they want to feed on those pests, the aphids, we don't know what will happen to the natural enemies that's just fed on these things that have been treated now with neonicotines and survived. I don't know why we don't have it. It's just not out there. This sort of information, we need a lot more research to say that these things are safe before we release them into the environment. And lastly, killing all your pests so early in the crop cycle is anti-IPM because it means you have nothing to attract and sustain your natural enemies. A low level of pests is a very useful thing in your crop because it will bring in those army of insects that want to feed on them and help you out. The beneficial insects, the good bugs that we talked about before. So step number 2, what can you do? You can go out and rearrange the insecticides in your chemical shed. Now this might sound like a bit of a funny one, but if you rearrange the chemicals in your chemical shed, the insecticides that you have there by their mode of action, the mode of action is printed on the front of the label, and most growers will be aware of what that number means. But it has come from what's called the Mode of Action Classification Scheme, the IRAC, the International Resistance Something Council. And they've come up with a scheme to help farmers mix up their chemicals so that they're not inducing resistance by continually using chemicals from the same group. So broadly, the higher the number, the newer the chemical. And you might wonder, why is that important? And it's important because more recently produced insecticides tend to be more highly targeted on the pest and a lot more gentle on your natural enemies. So you end up, if you superimpose that mode of action group that you've now got reversed in your shed, you don't have to go out and buy any more specifically to do this exercise. Then you have that, you would go out when you had a problem very early in your crop. If you do need to go out and spray, pick one from the higher groups that are much more likely to be friendly to your natural enemies. And again, this is all about harnessing the existing natural enemies or beneficials that you already have. Of course, towards the end, you've got to look out for withholding periods, and that's the time when some of the broad spectrums do come into their own and they can be useful as far as a pest management tool go. But again, what's your thresholds? If you wanted to find out more about the effects of pesticides on beneficials, there are a couple of resources out there now. There's one on the left produced by Hort Innovation and that group of other researchers below it, and it's called A Guide to Pesticide Effects on Beneficials. If you just type that into your browser, they will pop up. They're a fantastic resource. And if you're in doubt, there's lots of gaps in it. So hopefully there'll be some more research to fill in some of those gaps. But you can certainly, that's a great place to start. And the Cotton Pest Management Guide, from the Cotton Research and Development Council, or corporation, I think they are. They also have an effects of pesticides on beneficials. There's a couple of things that I don't really agree with, but it's a great place to start. So step 3, talk to your pest scout. To me, that's what I do. I'm a pest scout, so I may be overrating our importance here. What is a pest scout? So a pest scout or a crop checker, is someone who comes and virtually just will tell you exactly what you've got going on in your crop, whether you need to deal with it and how best to deal with it. So what I have found is that some growers just want to spray. That's fine. Some growers don't. So my advice then comes down to the conversation. This is what you've got. This is what we need to do, or we need to do nothing. This is what we need to do. And then you have that discussion around how we're going to deal with it. So why do you probably need one? If you're a small commercial grower, you probably don't need one. You probably get away with it. But if you're a larger on a commercial scale, an independent crop scout will give you data that you may not normally get. So often what I found, if someone uses someone within a company, for the larger corporate growers, sometimes priorities clash and pest scouting gets pushed down the line, and it doesn't happen. If you've got someone independent, your report's there every week, and it can tie in and link in with your spray day. You also get the fact that if you're doing it yourself, you've got to be careful because you have that heavy investment in your crop in both time and money. You tend to look a bit harder, and the harder you look, the more you find, the more you'll tend to spray. So what can I do for you on your IPM journey? Well, as DPI extension officers have become more and more scarce, 2 main types of pest scouts have replaced them. One is paid by selling chemicals, and one who gets paid by helping you spray less. Is there a difference? Not really. If you speak to your chemical reseller representative who is now looking after your crop and say to them, you just start that conversation, can you help me? I want to go down on a more IPM friendly path. I guarantee you they'll want to help. Well, almost guarantee you they'll want to help. You're going in there for lots more than just insecticides. You're probably buying fungicides and fertilizers and dog food and secateurs and all those other things you spend for you buy in the chemical resellers shop. So you have that conversation with them, and I think that pest scouts are fundamental to change. There's an army of people out there that know the pest, they know the district, they know the crops, they probably know the name of most of the farmers' dogs. They'll probably be bitten by 1 or 2. So there's a virtual army of people out there with the skills to change the way that agriculture is operating in this chemical space. What sort of data should you be getting from your pest checker? So I put in this is just an excerpt from a report I produced for some tomato growers. And you can see here, yeah, I've got a pointer. Here on the left, we got, I'm just looking at block B. These are dates, these are weekly checks. So each week I checked that many sites. Thrips in flowers are the big one at the time because they cause cosmetic damage to the tomato, and you can't sell them. They're downgraded. So this is the level of thrips we were seeing in flowers. And there were some other pests as well there that we didn't really need to deal with. We mainly were working on the thrips in the flowers. But over here is a list of the beneficials that we're seeing. So we didn't really see many to start with, but over the course of the crop, we're getting more and more of these beneficials coming in. So we've got predatory beetles, we've got ladybird beetles, we've got Stethurus, which is a predator. It's a ladybird beetle that just feeds on two-spotted mite. And these have all come in without any introductions. We're getting a smattering of spiders coming into the crop, and we're seeing a whole bunch of predatory mites. So all of these have come in. This is that type of background data that I'm talking about. And all we had to do in this period up here in these first few weeks is not kill them. Give them something to feed on. Make sure there's a little bit of the pest in there, and they will come in more than likely and do the work for you. One proviso here is, and I do this in my garden at home all the time, when something comes in, I will sit down, I'll watch it and wait. So if I get aphids come in, here we get the blue cabbage aphid comes in, and some years almost straight away we get parasitoids come in, tiny little wasps that breed in the aphids and kill them. And we can have them for several years in a row, and then suddenly there's nothing. The aphids come in, but the parasitoids don't. So there's a certain amount of unreliability in what they do. And this is where a pest scout can help manage that risk. If you're getting the comprehensive data, you will know whether you're getting that background control. So step number 4 is work with pest thresholds. A pest threshold is a level of pest pressure in your crop, above which economic loss exceeds the cost of treatment. Unfortunately, many chemical labels, including imidacloprid, say spray at the first sign of the pest. This is fundamentally un-IPM-y. I think that's now a word. I've used it twice, I think. However, in a system that's not dominated by chemical interventions, a few pests in your crop can be a really good thing. And I've put this picture, this photograph here, this image down here in the corner. I've included it because in my podcast that I did with Kate a little while ago, we talked about an example of grasses flowering that had covered lime trees with enough pollen to sustain a population of predatory mites, which then went on to feed on a pest mite called broad mite. So that was all a bit complicated, but in limes in far north Queensland, broad mite can be a substantial pest, and it can often require chemical intervention. But and it was purely because the grower had gone away on holidays, come back on a tractor slash, there was something wrong with it, so he hadn't got in and slashed. But you can see here these big heads of grass. This is Rhodes grass, and it had covered the trees in pollen, provided the source of food for predatory mites that then meant that the broad mite couldn't get established. And the point of that, and the reason I'm talking about that here, is when you're trying to work out a threshold for the first time, something to start with, you've got to consider not only the recent history of pest pressure on that crop, on that farm, but also the amount of natural enemies present. And this can be a bit tricky. So if you're seeing mites, for example, and you're also seeing predatory mites, how many of those predatory mites do you need to start exerting control? When can you say, I don't need to spray, and you can just let it go? And when do you get really nervous and or put a spray on. And I've tried both ways, and I've got a pretty good handle on it now, but it takes a bit of practice, and it also varies from farm to farm. So I would say, I'd recommend recent history, have a really good conversation with your grower, with your farmer, with your primary producer, come up with a threshold and try working at that. At the end of the season or mid-season, they might say, no, this isn't working. I think we could go a bit softer, so let's raise that threshold. Or they might say, no, I'm not liking the damage. We need to drop that a little bit. So it's all about these discussions and being adaptive as you're going through the cropping cycle. So again, get some preliminary data to work on and try and get that historical data to help you make that decisions of where to start. So before we go to the next one, I think it's number 5, I just thought I would try and explain things like the recommended rate and LD50 for people who are not familiar with these concepts. Most recommended rates on chemical insecticide containers that you'll find printed on the label, which is a legally binding document, it will say the recommended rates are there, and they will kill 95 to 98% of a pest population. And you think, well, why wouldn't you just put a bit more on and get up 100%? Well, the reason it's not that simple, and I'll tell you why. We call that the moron principle. You put more on, but it doesn't work. So the text in yellow is recently appeared on many insecticide containers, and I'm not sure if it's compulsory, whether it's a requirement or whether it's just by choice by the manufacturers that it goes on there. But it says some naturally occurring insect biotypes that are resistant to whatever product group you're talking about may exist through normal genetic variability in any insect populations. So when you look at the response curve, and I'll just highlight here in this graph down the bottom here, this is what we call the response curve. Now that response curve is produced in the laboratory, and it's the relationship between the dose down the bottom here and the percentage of mortality. So you can see when you get to about this dose, whatever it is, the mortality is starting to rise. And this isn't perfect. They don't all look exactly like this, but this is a representation of what most response curves look like. When you get to the stage where you're killing 50% of your population as your dose rate goes up, that's what's called your LD50. So you would think you would kill all or nothing. It seems more logical that you would kill all or nothing in a pest population, but it comes down to this insect biotypes that are resistant inherently to insecticides. So what does that mean for a recommended rate? We can see the recommended rate, which is on the label. That's the maximum you are allowed to use. It's gone up and up, and it starts to plateau. So as you put more and more on, less and less of that population are being killed. And you get to the stage where you think, well, we don't want anyone putting on more than this, because there's all sorts of models to say that it's going to be then inefficient. And that equates to about 95 to 98%. And that's why you can't just put a little bit more in and get up to 100%, because it just doesn't work like that. So the recommended rate tends to be a trade-off between efficacy and practicality. Probably about as good as you can get. So why am I banging on about that? I'm banging on about it because step 5 is coverage. Step 5, coverage is king. I call it the C word because it's not something you should use in polite company with your grower. They tend to get pretty upset if you're telling them they're not getting the coverage. Must be something else wrong, certainly not my coverage. The reason that it's important is that if you assume that, and it's not an assumption, it relies on it. So 95 to 98% pest mortality relies on 100% coverage. That is, every pest individual gets a lethal dose. If they're not getting that, if your coverage is dropping down to 90%, that's actually pretty good. Your efficacy is getting down to 85%. 80% coverage, 80 down to 60. your efficacy is getting down lower and lower. In my experience, most operators, if they're fairly good at what they're doing, are operating around this, and I'll explain a little bit why. So if you imagine that you're going on, you've got this insecticide you're putting on, you think you've got really good coverage, and you're really probably doing the best you can, you're still only getting 3/4 or less of the population that you're killing. So logic dictates, and it's what experience has shown me, that you will need to go back and spray a lot sooner. So while this might seem counterintuitive if I'm talking about IPM and how to get the best out of your insecticides, eventually, if you get your spray right, you will spray a lot less. So this sprayer here is spraying citrus, and this is why we generally have a disagreement between your pest scout and your grower on what the spray coverage is like. If you're a farmer and you're watching this go up and down your rows, you're thinking, yeah, it's all gone through, it's gone through the tree, I'm getting 100% coverage. Well, yes, it's passing through the tree, but often it will take the path of least resistance. So you end up with little tunnels that the spray is going through, and little pockets of dense foliage that it avoids. So it'll move around them. So you end up with quite significant pockets of untreated pests in your crop. Citrus is notoriously difficult to spray. The only time I've ever seen it done really, really well was with an oscillating boom, and the results were spectacular. He put on that much water with the product. He didn't have to water for a week either. It was really, really good example of spray once and spray really well. Down below here, this is typical for the Granite Belt here in Queensland. These are rows of tomatoes. You can see there's 5 rows to what we call a bay, and the spray is coming up here. And again, you know, it looks like it's doing a really good job, but right down here in the middle of these rows, there's very dense foliage and the leaves are hanging down, and they protect a lot of the inside of this plant from the insecticide. So it's swirling about in there, but it's not getting anywhere near the penetration that you need for effective pest management. On the other hand, opposed to that, on the right hand side here is a farm that I work with in the Granite Belt, and they have a drive row between each row of tomatoes. And what that means is you can come in with in this case, they actually use an orchard fan air blast sprayer. They turn the top nozzles off and they turn their pressure down very low, but they can come down each side of the row and get really, really good coverage. And what that means is when we eventually decide, yes, we have to do something, we have to put an insecticide on, it works as well as you could possibly expect. So they'll spray once, spray really well, and then that's it. It's really a much more spectacular way, much more efficient way of managing your pests. Now, there's a lot of talk about why they've set up like this, and the amount of tomatoes you get off over a 5-year period. They're much denser here, so you get a higher return. But as far as IPM goes, this crop here, next year, these guys will grow this row on this drive row, and this will become the driveway. This crop, they have to spell due to buildup of nematodes. So the actual, over the period of time, you get about the same yields off your block, but this one is grown with a lot less insecticide. So coverage is king. The next one I just wanted to talk about was the identify your top 3 or 4 pests. And the reason I raised this one is that IPM consultants, myself, I still think there's an element of this, is that we've overcomplicated. You imagine a farmer wanting to know the difference in the thrips that they've got in their crop. They're very hard to identify. You almost need to get a microscope, have a look down and count bristles in various places. But it can be a much more broader approach than that. Most farmers will know and be able to identify the top 3 or 4 pests that give them grief year after year. And those are the ones that you want to plan for. So in capsicums, for example, and tomatoes here in the Granite Belt, Things like caterpillars, thrips, fruit fly, and mites were probably the big ones that you worry about. And the idea behind a good IPM program is to start with them. So that's the place you start. Have a program of things you can put in place, and just be able to identify the top 3 or 4 and not worry too much about the finer detail. Eventually, yes, you might find that better ID would have given you a better outcome, but as a place to start, you can certainly get away with identifying your top 3 or 4. 7, farm biosecurity. Most people are aware of this now. You see these signs out on a lot of farms, and most primary producers have them on their gate now. And the idea is you prevent pests and diseases from getting there in the first place. Things like garden weevil, common garden weevil, which is a pest in vineyards in southwest WA. Could only really get there. It'll take them years to walk there, so they've probably been brought in by someone on clothing or on machinery. So just be really aware of that. If you don't have garden weevil, make sure that you don't get it. But more importantly, an aspect that not a lot of people really think about is within farm. So as a general rule, if you're working in tomatoes, say, work on your youngest or cleanest blocks first. So if you have a block that's a little bit older than the others, that has got mites, has got russet mite in it, make sure your pickers aren't going through that one first and then the others after it, because that way they'll spread it. So if you go through your cleanest first, pick your clean ones, and then move into the other ones, you'll be less likely to spread these mites. And note also that air blast sprayers are pest spreaders. So if you're spraying for mites, and you start at the pointy end of your block that has the most mites, as you go past, you're going to spread them. If you spray from the outside to the inside, you're going to spread them straight away down into your crop. Unless you have a miticide, it's going to be a significant spread. So again, start from the cleanest end and work towards where the hot spots are. Most growers will know where the hot spots are on the farm. So number 8, we're getting there. Acknowledge that in most cases, insecticides have no impact on the prevalence of insect-vectored disease. Now, this is often a hard sell. It seems really intuitive that once you see something going on, it might be tomato spotted wilt virus, it might be tomato big bud phytoplasma. These are all spread by insects. You might see them in the crop, say, well, I need to do something about that now. It's too late. The science is telling us really clearly it's too late, and you're wasting your time and energy trying to spray it out because, like I say, it's basically too late. So tomato big bud phytoplasma manifests itself like this one on the right here. And on the left-hand side here, you can see that this is a little block that traditionally gets a lot of tomato big bud phytoplasma in it. But this was a particularly bad year. And so the grower went very hard from week 1 and sprayed with broad spectrum insecticides. And really, it's hard to argue. You've got to get a crop off it. That's what you're doing for a living. Who's giving it a red hot crack, and it made no difference. So they're still blowing in laden with pathogen and pumping it straight into your crop. Very, very difficult to control with insecticides. So that's the last one talking about in a commercial setting. And these are the 8 steps that will start you treading more softly and starting to harness that whole army of beneficials that just want to eat your pests, and all we've got to do is stop killing them. These are some ways that you can lighten the pressure on them and stop killing them. So the next thing I was going to talk about was what can we do in the home garden? So if we assume that we know that insects are declining around the world and we want to do something about it, what are some of the things that we can do about it in the garden at home, around the house at home? And one of the really encouraging things about working in what is otherwise a pretty depressing space around this insect decline is that there's so much that we can do straight away that won't cost us an arm and a leg. We could actually fix this whole decline thing fairly quickly if we put our mind to it. So I put these references here at the front because they are really good resources to check out. Go and have a look at them. Just chuck them in your browser. These will pop up. So yeah, have a look at them online. They're a resource for insects. They find mates at insects at flowers. Insects eat each other at flowers. They find and mate and feed. It's just like this carnal house of activity. They're in there for pollination. They're in there for to feed on the nectar that that flowers are producing to attract insects. So plant flowers, plant flowers, plant flowers. That's the best thing you can do. Native plants are best. And the reason they're best is because they're more likely to have the right nutrition at the right time. So planting flowers that insects are going to, unless you've got the timing right, can be a little bit less helpful. Not less than helpful, but less helpful. So stick with natives, things that are native to the region that you are planting the flowers in. But there's one thing that we really need to be very aware of in this, and it's a very, to me, it's quite upsetting. And it's the fact that potted plants, the potted colour, the very plants and flowers that you go to buy from your nursery may be treated with imidacloprid or other group 4A insecticides at higher rates than are allowed in agricultural settings. They can be used as soil drenchers in a way that's unprecedented. And the reason that's a worry is that if that plant has been treated with the neonicotines, that'll be taken up into the plant because they're systemic. The very pollen and nectar that you are then going to plant out in your garden can be toxic to the very insects that you're planting them out for. It is, to me, an absolute tragedy, and it's an appalling misuse of insecticides. I can't stress this enough. I've been actually really upset by the whole possibility that these beautiful things I've been putting out in the garden could be toxic to the very insects that I'm putting them out there for. Why has it come to pass? Well, there are two pathways to the legal application or to the legalization of the application of imidacloprid and other neonicotines in the nursery industry. One is via the label, which appears on imidacloprid. It says you can apply it at this rate for these pests, and the other is via a permit system. So just how all this works, the APVMA regulates and approves uses for insecticides in Australia. The APVMA is the Australian Pesticides and Veterinary Medicines Authority. They regulate how pesticides are used in Australia. So let's say a chemical comes on the market, but it doesn't include you and you need it for your crop, and you've got a really good legitimate argument for it, then you can apply to the APVMA for what's called a minor use permit. This minor use permit will allow you then to legally use that product on your crop. Now, the Green Life Australia, Green Life Industry Australia are the representative body for wholesale nurseries and people who sell potted colour in Australia. They hold the permit for this use. They do, in defence, they do put a lot of work into making resources available, and they are really good resources, making resources available to use alternative ways of controlling to getting IPM into the commercial production of pot plants. And they've done a pretty good job with that. But the fundamental thing that really gets me is that there's a very real possibility that these neonicotines are in the flowers that we are planting in our garden, and they're in there without our knowledge, and they're in there without our consent. That's my bugbear. So the second thing we can do is reduce light pollution. Dark Sky International are actually a bunch of astronomers, and they've come up with some ways that we can reduce light pollution, and it's become accepted by various groups. Entomologists and insect ecologists agree that they're pretty useful ways. It's become a bit of a standard, international standard of how we can reduce light pollution. So use lights only as necessary. Use them directional, so you're pointing at the ground, not beaming them out to the sky. And the whole idea around this is to stop insects being attracted to lights, because about 30% of the insects that are attracted to lights don't survive to the next day. So use them at a lower level as you can. Use some control, things like motion sensors. Use a warmer color. They're less attracted to the yellows than they are the harsh blue colder colors, as they call them, the ultraviolets. Next thing we can do is avoid insecticides. Tread carefully in your garden. You can go into your local hardware store and you can buy neonicotines off the shelf and use them in your garden. It's really seems a strange thing to allow. Most farmers are now required to do pesticide application training and become accredited before they can use them, but there's no similar regulation for people using them in the garden. I'm not saying we need to regulate our way out of this, but we should be choosing chemicals that don't contain neonicotines if we can. One of the things about it is for the domestic use that you get in your hardware stores, if you go and buy them in hardware stores, they don't need to be labelled with the chemical group that they belong to. So often group 4A isn't stamped on them. So go armed with the knowledge that you can avoid neonicotines. You don't need them. Farmers don't need them. We don't need them in our garden. We can get away much better without them. There are much better options out there. So why am I banging on about this? Well, this one, clothianidin, it's an active ingredient in a thing you can buy off the shelf, and it's for controlling lawn beetles. Christmas beetles are lawn beetles. They're scarabs that feed on grass roots. So where have all the Christmas beetles gone? Have a look at Invertebrates Australia. Great organisation, great website, lots of information there. You can get involved with the work that they're doing if you're anyway inclined. But really one of the most important things you can do is stop putting neonicotines out in your garden. And other pesticides, tread as carefully as you can. It's hard to imagine there's actually a need in your garden for anything other than a few botanicals, maybe a bit of white oil every now and again. The less harsh, the more gently you tread, the more natural control you'll get. So convert your lawns, number 4, convert your lawns into a more natural habitat. When you realise how biologically sterile a lawn actually is, it all becomes really easy to understand. You're trying to provide more environments for insects to flourish. Number 5, leave the leaves. If you feel you do need to really rake them up, put them in a pile and just let them rot down, let them compost. Compost is the stuff of life. It's where insects and other invertebrates, it's where bacteria and fungi and beneficial nematodes, it's where life happens. So as much compost as you can get into your gardening, the better. Don't burn your piles, leave them to rot down. Be wary of flea treatments on dogs. This isn't one that I would really have put down off my own back, but it appears fairly commonly in things we can do about the insect apocalypse in our own backyard. The amount of imidacloprid goes on to a dog, that's Sparky in the foreground. He looks guilty. He's done something wrong for sure. And that's Gus. He's the other little one. The amount of flea treatment that goes on to, the amount of imidacloprid that goes on to a dog in a flea treatment can kill a ridiculous amount of bees. Ridiculous. Why do we carry on about bees? Because that's where the research is. I call them honeybee equivalents. Some findings are saying that bees are more resistant to imidacloprid or to neonicotine. Some are finding they're less. So I'm using them because that's what we know. So it can kill, I don't know, it's 7 million bees. And because you have to keep reapplying it, in between treatments, your dog is shedding that neonicotine into the garden. It's coming off in skin flakes and in urine and in feces, it's all being shed by your dog into your garden. So you are toxifying your garden just by putting it on the back of the neck of your dog. Choose something else. As soon as they go for a swim, all that ends up in the water body. So again, cut your carbon footprint is another really big one, because there's an interaction between climate change tends to exacerbate a lot of the effects of these other drivers for insect decline. So I think the last slide or two is going to be, oh yes, there's two more things you can do. So what else can you do? If you're not a gardener, if you're not a farmer or a gardener, what else can you do? Well, there's a couple more things you can do to help. One is the APVMA is reviewing the registration of neonicotinoids in Australia, and the first decisions will be released later this year. I can't recall the exact date. I think it was about 2018-19 this review has started. It's taken an awful long time. It doesn't really smack of an organisation that's going to do a swift, decisive action. So let's wait and see in that space, I suppose. But if you go to the website and have a look, you just type in neonicotinoids APVMA review, the website comes up. You can click on subscribe, and they will send you emails when things come out. So when there's any news on this, when the decisions come out, they'll be up for review. So go and have a look and make comments. Tell them what you think. It's an opportunity for actually everyone to make a difference. And the last thing is buy imperfect fruit. There's quite a bit of work done on how this can reduce the pressure on farmers to use insecticides for cosmetic purposes. So both of our supermarkets have lines, the Odd Bunch and Perfect, I'm Perfect. They're lines you should go and choose from. So if we can empty those shelves as quickly as they're stocked, the message will come out really quickly that we do not need and do not want perfect fruit. So, case study, we're going to talk about red-legged earth mite because it's an issue in the southwest WA. And Kate from the Land Care LCDC, Lower Blackwood LCDC, has asked me to have a quick chat about it. So I haven't worked with red-legged earth mite as a pest management consultant. I've worked with it only as a farmer and watching it eat my clover. But there is a lot of work gone into it from various organisations, and there is a lot of information out there on the internet about how you can go about improving your management rather than just relying on sprays. So we have Agriculture Victoria has put one out, Caesar Australia, the GRDC, which is the Grains Research and Development Council, I can never remember, corporation, no, I think it's council. And then there's the independent Australian Journal of Experimental Agriculture publications and CSIRO. All freely available online. Just chuck them into your browser. If you get stuck and want to get them, I can easily send you a link. So basically, good management of a good IPM program for red-legged earth mite starts the year before. So if you're planting a winter crop and it's being affected by red-legged earth mite, then you should be looking at implementing controls towards late winter, early spring, the previous year. So if you're planning on a crop, you'll need to be going over the next couple of months. You'll need to be starting to manage for next year's winter's crop. And this diagram here, I don't think it's come up particularly well on the screens. This here is the life cycle of red-legged earth mite. In the green is the winter-spring cycle when the mites themselves are active. So once the summer ends, we'll just start here. You get 5 millimeters rain over less than 5 days, followed by 10 days below 16 degrees. The eggs hatch. And these eggs hatch, they mate, they breed, and the winter eggs are laid. This is where the second generation comes in. So we end up with overlapping generations, 2 generations. And this is September, August, September time. And this is where they're laying summer eggs. These are the eggs. I think this is the 3rd generation here. So these summer eggs will still hatch. And then it comes up to about October, November, when things are starting to get hot, they're drying out. And from then on, any eggs start to diapause. Any eggs from this generation that haven't hatched will start to diapause. And then they are inactive. So the entire population of red-legged earth mite goes through these summer months as eggs, and bang, that's when they hatch. So when do you want to spray? If you're going to rely on a spray, when do you want to do it? And this product here, Time Right, it's an app. You can download it free. I've done it the same. And this is the graph it produced for me when I put in my old postcode, and I think it's from Palgrub, from when I used to live down there in Quinninup. And this program will give you, by your postcode, it will give you the ideal time to spray if that's what you need to do. Really good product. I've heard people absolutely swear by this. It works really well. And what it does is it allows you to spray before summer diapausing eggs, before this period here, before eggs start to diapause. So you're hitting the population before they're going to overwinter. And that's if you just want to rely on an insecticide or a miticide. If, however, you decide that you would rather not use an insecticide, this is a table produced by the GRDC, Grains Research and Development Corporation from the Australian government. You can see here IPM strategies for red-legged earth mite. So from the previous year, I was talking about pastures around winter, spring. They're saying keep your pastures short in very early spring, ideally graze down to 1.4 tonnes per hectare. Usually 3 to 4 weeks prior to the application of your Time Right. Heavily grazed paddocks will not require an insecticide spray. So this is a key element to the cycle. So if you are having trouble with red-legged earth mite, I strongly recommend that you have a look at the information that's out there and available. And lastly, but not least, remember, time is fun when you're having flies. Thank you very much. Good on you, Kate.
Thanks so much, Ant. That's really, really fascinating as usual. I'm not sure how many of the audience actually listened to the podcast that I recorded with you, but this really just grew on what you said in that one. But I'm just looking down, it doesn't look like anyone's actually asked any questions, which is possibly because you've explained everything so well. But
not usually.
A couple of comments. Of course, it's very sobering thought, all those stats and figures, and particularly around the neonicotinoids. How easy do you think it is for people to get hold of seed that hasn't been treated with neonics from commercial?
It's not easy.
Yeah.
It's not easy. I had the experience myself. I bought a whole bunch of seed to go down the regenerative agriculture and build up my soil carbon. And I specifically requested organic seed. That's what I was searching. They said, yeah, we've got some here. And I sent it up, and half of it had been treated with neonicotine. So I had to send half of it back. So it's actually quite hard to find. It's so accepted now as common practice. It's hard to really work out how that's happened. There's no real data, even from the chemical companies, to say this is what you need. You would think if it was so beneficial, the data would be there to tell us, but there isn't. And anytime someone's looked, it's said quite clearly, we don't need it. I don't know how it has become so ingrained in all our systems. If you were to look at, for example, you're a seed seller, you sell seed. The guy next door started selling this neonicotine treated seed, so people are starting to think it's better. So if you sell seed that has maybe a risk of establishment not working, or the drive for you is to sort of get on get on board to avoid any possibility of that sort of trouble. It's just a funny thing about us that we've jumped on this thing, and we're here now, and we've got to stop it.
Yeah, I'm wondering. We've got our local nutrient supplier who we order a lot of seed through, does his very best actually, and we are able to get quite a bit of seed that's not treated. And he'll certainly let us know if he's not able to. So my suggestion for everybody is, if you're not from this region, is go and make friends with your local ag supplier and see if he can help source untreated seed for you, and quite possibly might be able to. And I'm just wondering about, you said about nurseries treating seedlings with neonics. It's something I hadn't thought of, and I'm wondering whether, I'm pretty sure they wouldn't, but I'm wondering if the local tube stock suppliers would use neonics as well. What's your experience with that? Do you know, for natives?
Well, that's a really good question. It's a really big subject. I've been in contact with representatives from the Green Life Industry Australia, which are the peak industry body for nurseries. They've put a lot of work into promoting IPM and using natural remedies and non-toxic remedies. But the brutal truth of it is they don't dictate to individual nurseries what they can and can't use, or not what they should and shouldn't use. They can't dictate that. So while they have put a lot of effort into promoting the use of IPM in the nursery industry, they also hold the permit that allows. I'll just take a step back here. So when a chemical is allowed to be used in a certain way on a crop or in a nursery, it has two pathways to get there. One is a mention on the label. So the label, the chemical manufacturer or importer might say, I want to use it on this. This is what my chemical could be used for. APVMA will say, yep, okay, that's fine. If it doesn't include something that an end user might like, they can apply to the APVMA for what's called a minor use permit. So the Green Life Industry Australia hold the permit. They are the holders for the permit that allow a certain amount of neonicotines to be used as soil drench on potted plants. So at one hand, they are not promoting its use, but they are, on the other hand, they are allowing it, facilitating it. Yes.
Well, I guess the best thing is where you can ask.
Well, I have done exactly that. There's a couple of other things to mention in this space. One is I've contacted several wholesale nurseries to find out, because I was devastated that something so fundamentally beautiful and endearing and induces all these happy thoughts, like a flower that you just put in your garden and it's full of insects, could be toxic. So I've done quite a bit of reading around it, and I've spoken to as many people as I can. Wholesale nurseries, generally the ones I've spoken to, don't use it. Bunnings have had, and I've hardly ever used any brand names or company names, because I don't want to be pointing a finger. It's not what I'm about. But Bunnings have done some really cool stuff in this space, so it's worth a shout out to them, that they have put in place conditions on their contractors, their suppliers, that they don't use neonicotines in the production of their plants. So there are some good news stories there. But I would imagine that testing and compliance is really, really difficult. It's expensive to get. It can be hundreds of dollars for a single test for neonicotine. So how well that's enforced, I'm just frustrated that there is a possibility that these things that I am buying in good faith, they're unlabeled, they're done without our knowledge or consent, could be poisoning the very garden that I'm putting them in. And I just get very, sad about that.
Well, we've got, moving on from that a little bit, we have got a question in the chat box from Rob Theron. Thanks, Rob. He says, we also have trouble with African black beetle eating ryegrass seeds. Do you have any control suggestions?
Good question. No, I don't. Not off the top of my head. I would, without having a look at the system that you're operating in, I wouldn't make recommendations for chemical control. I could have a look around, see what else, other options are available, but I can't just pull something up like that. No, it's not something that I've worked with, so I don't
Rob,
have something I could just suggest like that.
Rob, we might see if I can follow up with Ant after this webinar, and he might be able to help us out with something afterwards when he's had a chance to have a look at it. I might just go back to the red-legged earth mite, because it is a major thing here. And
Yep.
I couldn't see on the slide, I think it was slide 38 that you had there.
Okay, I'll
said,
just scroll back.
You scroll back to that one. No, yeah, that one there. So I just want to make sure I understand this correctly. So they lay eggs twice, once in the winter and once in the summer. And you're saying that
there actually can be several generations.
Okay.
There can be several generations. So once the eggs hatch, and it's driven by rain and temperature, so it's all driven by the mite needing to know that it's in winter. So it needs to be cool. It needs to get some rain, and then the eggs will hatch, and then they'll grow as quickly as they can. They'll mate and lay eggs. So there can be several generations laid, or at least two. There's time. But when it comes to spring is when they start to lay eggs that will diapause, because very few mites themselves, adults, will survive through the summer. Everything dries out, the mites die off. So you've got over summer, you've got an over summering population of eggs. They go into diapause.
And so is that like what we call maybe the biological weak link at that time then? Or I can't see on the graph you've got there, I can't actually see what the is that the middle of the year? I can't see when the timing is, what the time frame is for that.
Okay, so this here is August.
Yeah.
No, sorry, March, April. I'm struggling to see it too. I normally have things a bit bigger than this. So that's March, April, and over here is September, October.
Yep.
So this is when it starts to rain. This is like the graphical representation of the break of the season. It starts to rain, starts to get cool. They start to lay their eggs. Oh, sorry, the eggs hatch. And I think this represents the second generation. So there's one or two, or sometimes three generations over the winter. And down here, they start to lay their summer eggs. And when they're laying them up around here is when they start to go into diapause. So what that means is they virtually become inert and they just sit in the soil.
Yeah.
So they're actually quite hard to kill. The time you want to really start getting ready for here is when it is here. So if you graze heavily, that's one of the things. I'm just going to flick to the next slide. If you graze heavily here, it's talking about some of the things you can do from the previous year to help manage the pests in your crop for the current year. So I'll just flick back again. If you should be getting ready for planting your winter crop in a paddock that you're going to do here, you should be getting ready here.
Okay.
So what you want to do is get these mites. You want to control them before they start laying their diapausing eggs. So you can do it if you've got a paddock that you want to plant next year. Chuck your sheep in and eat it down here.
Yep.
It'll sit there pretty ugly and bare, and there might be other reasons that you don't want to do it, but you won't have that same red-legged earth mite issue next winter.
Yeah. Okay. So hard graze, but hopefully not bare ground, because that's not good. We don't want that.
It isn't, and there is actually a recommended tons per acre measure in this literature that will tell you, you don't have to go past here. This is what you want to get it down to. I can't remember what it was off the top of my head, but it's all there in the data. So if you start reading around it, the answers are there.
It's interesting actually, because we, I suppose, with a grazing hat on, we're possibly trying to leave some paddocks with standing feed over the summer for a number of reasons. But I guess it's another tool in the toolbox. A lot of us have been thinking, you graze harder at the end of the summer season as a sacrifice paddock, and then you seed that paddock, but that hasn't really helped if you've got a red leg problem in that case,
Yes.
is it?
Yeah, absolutely. But they're mainly a pest of the broadleaves. So things like capeweed and clovers and things like that are what they prefer. So you can plant things that break that cycle. You could just plant grasses for a year.
Yeah. Well, I suppose what we're trying to do is get more diversity into our pastures with broadleaves, because we pretty much have.
Yes, exactly. I'm in the same boat, but we don't have red-legged earth mite.
Yeah. Well, anyway, that was fascinating. It doesn't look like we have any other questions. Just some thanks. So I think we can probably finish up now. So thanks so much, Ant, for another really informative session. And it is pretty frightening, the prospect of insect apocalypse. Let's hope we can all do our bit to change the trajectory that we're on. And I do hope
to say. Sorry, I'll just have to say that one of the things that really keeps me motivated is not the doomism of it all, but the fact that will be relatively easy to fix.
Yeah, that's it.
Yeah.
And I think if most people just were aware of the statistics and understood certainly about the neonics, that it's more preventative than actual anything else, then
yes,
it would be a different approach for sure. So thanks once again, Ant. That was really great. And for our audience, just before you sign out, perhaps I can get you to complete our webinar evaluation form. I need this for our funder, but also I'm out of interest to see how much you gain from it. It'll only take you a couple of minutes, and it's super helpful for us in making sure that we're providing the content that's most important to you. Also, as promised, I will be emailing out the recording of the webinar. I'll try and do it this week, and if I can't get to it, it'll be next week. But it will be coming. Plus, I'll also post it in the knowledge bank of our online community, Talkin After Hours. So if you're not a member yet of that community, I'd strongly encourage you to join. It's free and it's chock full of really great information and opportunities to connect, ask questions and chat with other members on topics just like this. And you can register on our website at lowerblackwood.com.au/Talkin After Hours. So that's it for me, I think. Thanks once again to Ant and to RegenWA and State NRM for their support on this webinar. And to the rest of you, enjoy the rest of your day. Thanks. And Ant, we'll talk off screen later. Thanks very much.
Thanks, Kate.
Bye.
Bye.